So in this example, we have a survey of 1,000 people, and the respondents were asked if they plan to buy a house in the next year. Right? We use the responses to construct this table. So as you can see, we have two age groups, right? People from 18 to 29 and then 30 plus. And then their responses were either yes, no, or unsure. If you recall from earlier in the course, this is what we call a cross tabulation. And the way we interpret the cross tabulation is that the numbers in the interior of the table, so these numbers, they give you the numbers of observations that satisfy both the row and the column categories. So for example, you have 131 people who were not going to buy a house in the next year and who were 18 to 29, right? And so on and so forth. And then the numbers on the margin give the number of observations in the horizontal or vertical categories. Now, one thing we can do with this kind of table is that we can divide the whole table by the total number of observations. In this case, it would be 1,000, right? If you do that, you end up with a table that contains a bunch of probabilities. So you still have these age groups, and then you have the three responses. So you end up with 0.134, 0.131 here, and then 0.002. Then you have 0.293, 0.432, and then 0.008. And then you have 0.427, 0.563, and then 0.1 or 0.01. Then you have 0.267, 0.733, and then 1. So this is the our new table. Okay. Now, how do we read this table? So for this table, the numbers in the interior, so these numbers, the numbers in the interior of the table give probabilities of intersections of events. For example, the probability of the intersection between no and 30 plus is 0.432. Now the numbers on the margins, right? These numbers, so the numbers on the margins give probabilities of the individual events or the individual categories. So this kind of table is extremely powerful in a sense that it gives you all the information you need to compute a bunch of conditional probabilities. So let's look at a quick example. Let's find the probability that someone answer yes given the fact that he or she is older than 30. So I think the most straightforward thing to do here is to just apply the formula, right? Because we already have a bunch of probabilities. So here we want to find the probability that of yes, right, given 30 plus. This is going to be equal to the probability of the intersection of yes and 30 plus divided by the probability of 30 plus. According to the table, the probability of the intersection of yes and 30 plus is 0.293. And then the probability of 30 plus is 0.733. So if you do the math here, you get 0.399 something, which you can just round to 0.4.